Institute, CSIR, Madras Complex, Taramani, to accept our greetings to give the felicitation address. Next, I'd like to thank our guest of honor, Dr. Bu Tong Hung, Director of Data Analytics and AI Lab, Tu Do Mot University, Vietnam, who has accepted to give the keynote of address. So we have 97 participants in total for this STTP. Among those, number of students are 82, research scholar is 10 in number, faculty is 5 in number. So the major participants of this STTP are students only. So the highlights of this STTP are, this STTP is going to be a hands-on experience throughout the training. At last, we'll be conducting a quiz competition. The winning students will get the internship opportunity in ABE Semiconductor and Design. Participants can carry out the industry projects in association with ABE Semiconductor and Designs and product development. And finally, we'll be providing the course material and recorded videos also. So dear participants, many magics are going to happen in this STTP. So make use of this opportunity. Thank you all.
If your actions inspire others to dream more, do more, and become more, you are a leader. I would like to invite Dr. Maria Joshi, Department of ECE, SRM Institute of Science and Technology, to introduce our chief guest, Dr. Kalpana Ma'am, Principal Scientist, CIRI, CSIR.
Thank you, Kolanji. Good morning to everyone. I'm Dr. A. Maria Joshi, Assistant Professor in Department of ECE. It gives me great pleasure to introduce our chief guest, Dr. D. Kalpana, to this short-term training program on cognitive learning framework for IoT devices.
Yes, sir. Completed the writing part. Yes, sir. Okay. You can start the simulation. Once you got the output, share your screen and show your output.
Dr. Kalpana is a principal scientist in Central Electrochemical Research Institute, CSIR, Chennai. Dr. D. Kalpana has completed her PhD in Physics Electrochemistry at University of Madras in the year 2004, MPhil in Physics at Anna University, Chennai in the year 1998, PGDCA in Computer and its Application at Bharatidasan University, Trichy in the year 1998, and MSc in Physics at Bharatidasan University, Trichy in the year 1996. Her area of specialization is solid-state physics and material science. She has 7 years of teaching experience and 20 years of research experience in materials electrochemistry with some special emphasis to batteries and electrochemical supercapacitors. Her research activities include synthesis and characterization of PT-based, non-precious metal and non-metallic catalysts, catalyst support materials like graphite, nanofibers, multi-wall carbon nanotubes, and graphene, preparation of nanomaterials for energy storage applications like batteries, fuel cells, and supercomputers, development of conducting carbon, metal oxide, and polymer-based supercapacitors, synthesis and activation of carbon from various natural sources, development of hybrid supercapacitors, recycling of waste materials, electro-co-deposition of conducting polymers. Dr. Kalpana has received Young Scientist Award in the 2nd International Conference on Electroactive Polymers, Materials, and Devices held at Goa in the year 2007. Dr. Kalpana has won the first prize and received this paper award in the 12th National Convention of Electrochemists held at Madurai in the year 2005. Dr. Kalpana has received this paper award in National Conference on Power Electronics IEEE PICON held at National Institute of Technology in the year 2003. She has also received the Best Paper Award and bagged gold medal in the 11th National Convention of Electrochemists in the years 2001 and 2002. Dr. Kalpana has received the Outstanding woman of the college from the Government College of Women, Pudukkottai, during her undergraduate in the year 1994. Dr. Kalpana has received Senior Research Fellow from CSIR Delhi in the year 2000, pursued postdoctoral fellowship from Chonam National University, South Korea during the year 2008 and 2009, INSA Visiting Scientist Fellow from Indian Institute of Science, Bangalore during the year 2016, and also she received the Fellow Academy of Science from Chennai. She has undertaken various projects from BHEL, Hyderabad, CSIR, Naval Research Board, DRDO, and so on. She has more than 50 publications in reputed national and international journals. She is one of the authors in the book chapter titled Graphene-Based Nanomaterials for Solar Cells, published in Elsewhere in the year 2017. She has reviewed many projects from Kazakhstan, DST, and CSIR Delhi. She is also a life member of SAEST and the Indian Science Congress Association. And she is a reviewer for various journals. And she has a recent development in which she has developed a fuel cell power, a perfect off-grid solution. Dr. Kalpana, Madam, we are grateful to you for accepting our invitation and to be the chief guest of today's event. I would like to invite Dr. Kalpana, principal scientist in Central Electrochemical Research Institute, CSIR, to give her felicitation address. Ma'am, please.
Thank you, Mrs. Maria Joshi. Thanks for the good introduction.
Thank you.
Very good morning, one of you. I'm Kalpana from CSIR, CECRI. I would like to, first of all, I would like to thank the organizers for inviting me within a short span of time. I think I'm audible to you all. Is it so? Am I audible to you?
You're audible.
Yeah, okay. So
Yes.
It's a great thing that when I was reading the agenda, that people are going to light the Kuttu Valakku. I was wondering how you are going to do that, but you have used IoT for this also. Very happy. And so I would like to thank the organizers and SRM, especially Dr. A. Atif Shah, founder and managing director of ABE Semiconductor Tube Science, and Mr. T. Vignesh Prabhu for arranging this wonderful short-term training program, which is very much useful for the faculty members, research scholars, UG and PG students, and industrial personnel. I think you have drafted a very good topic for this, which is the current topic for this. Before going into this, I would like to introduce myself, where I am coming from, so that in future also, if you want to have collaboration or students or from the SRM or any other colleges, if you want to have any kind of research work, you can approach us. So I'm from Council of Scientific and Industrial Research, which was established in the year 1942, which is an autonomous society with the Prime Minister of India as its president. And we have 37 institutes all around India and 3 research organizations in the world. And CSIR expertise and experience are embodied in its 4,600 scientists and 8,000 scientific and technical support personnel and 8,000 research students. So we have all the sophisticated infrastructure and scientific technical manpower. CSIR covers almost the entire spectrum of scientific and technical R&D, national and international importance. So this ranges from aerospace to ocean exploration, microelectronics to structural and environmental engineering, smart affordable materials to microelectronics to structural and environmental engineering, smart affordable materials to mechatronics, petrochemicals to synthetic biology, and from robotics and micro machines to drugs, pharmaceuticals and energy technology, etc., etc. And me from Central Electrochemical Research Institute, situated at Karaikudi, which has the headquarters, and we are here in our unit at Taramani. We have a proud family of 700 members. It's the largest research establishment for electrochemistry in South Asia. So we also serve a launching pad for a multitude of technologies for the Indian electrochemical industry. We have 755 patents, 50 processes, 600 sponsored and granting projects, 450 licensee, and 5,500 research and review papers that the institute boasts of our ample testimony. So I'm just sorry, uh, I'm just sharing this. We are the gamut of problems covering all facets of electrochemical science and technology, which include corrosion and science, electrochemical material science, electrochemical power sources, electrochemical pollution control, and fundamental electrochemistry. So this is really it is about this program IoT, Internet of Things. Of course, Internet, a word known by every human across the world. Um, so it's become an important part of our life, which has revolutionized communication systems and even our attitudes towards everything. So this IoT gives us the detailed vision about the networks of physical objects that are embedded with the sensors, softwares, and technologies for the purpose of connecting and exchanging data with other devices. Uh, to simplify this, what I have learned is the Internet of Things or this IoT is influencing our lifestyle from the way we react to the way we behave. So from air conditioners that you can control with your smartphone to smart cars providing the shortest route, or your smartwatch, which is I think this IoT is a giant network with connected devices. So these devices gather and share data about how they are used and the environment in which they are operated. So it's all done using sensors, and sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, traffic lights, and almost everything that you can come across. So I think with this current topic, it's great that Department of Electronics and Communication Engineering, which is the oldest and well-established department of the great SRM University, has taken this topic and giving a short-term training program for the faculty members, research scholars, and PhD students. And the topics covered is also very good. I think that they introduced the cognitive learning frameworks. They have the practice. You're going to learn the practical aspects of selecting the cognitive learning framework, and they're introducing the ARM and embedded processors to be hands-on experience using this ARM. And you're also going to learn about this Internet of Medical Devices, which is very useful for this current scenario, and hands-on experience on cognitive framework, for computing devices, etc., etc. I think the topics going to cover is very good the topic, which is very much useful for the need of this hour. And this program, the idea behind this Internet of Things is to have devices that self-report in real time, which includes improving efficiency and bringing important information to the surface more quickly than a system depending on human intervention. I think this I think 1 week program will definitely fit. As Madam told, you'll be given a training program for selected board. I hope this HTTP will be very much useful for you for the faculty members, as I told you. I wish this STP program a grand success, and I thank the organizers and the department, my director, for the opportunity to give up. Good luck.
Thank you, ma'am, for your valuable talk. As you told, we also very eager to have a collaboration with you. So in future, we can have that, ma'am.
Sure.
It's important to be a person of honor than be a person with wealth. I invite Mrs. Aarti Ma'am, Department of EC, to give a brief introduction about our guest of honor, Dr. Bu Tong Hong, Director of Data Analytics and AI Lab, Tudor Mott University.
Excuse me, Maheshwari, one second. I'm sorry, I forgot to mention Dr. Buithang Hang. Thank you, Dr. Buithang Hang, for being accepted as a guest of honor. I'm sorry, I forgot to include. Sorry.
Okay.
Yeah, please go ahead.
Thank you, ma'am. Good morning, all. I'm Aarti, Assistant Professor. It's my immense pleasure to welcome our guest of honor, Dr. Viu Tang Hang, Director of Data Analytics and Artificial Intelligence Laboratories to Dartmouth University, Vietnam. He received his MS degree and PhD degree from Japan Advanced Institute of Science and Technology in 2010 and 2013. He has completed 2 projects, published 8 journals, 11 book chapters, 26 international conference papers, and 15 domestic conference papers. He got 3 Best Paper Awards of FICTA 2018, RICE 2020, and ICAIAA 2021. And he is selected as excellent scientific researcher of Dartmouth University in 2019, 2020, and 2021. He is a reviewer of many journals and conferences. His main research area of interest are natural language processing, machine learning, machine translation, text processing, data analytics, computer vision, and artificial intelligence. I welcome you, sir, to give a keynote address on malware detection in IoT device based on deep learning approach. Sir, please.
Sir, you can share your screen, sir.
Okay. Good morning, everyone. Today, I'm very happy to come back to your university in the second time in the short-term training program on currently learning framework application for IoT device. Today, my topic is malware detection in IoT device based on deep learning approach. I'm Boo Hong from the Data Analytics and Artificial Intelligence Laboratory, Engineering Technology School, Dartmouth University. Here is the outline of my presentation, but I will talk about the introduction, what is the IoT device and malware, and how to detect malware. And nextly, I introduce some deep learning technique and apply deep learning technique for the malware detection, and give them the sample experiment. Lastly, I will give conclusion. Now let's begin with the introduction. IoT device. This means that the device has a sensor attached to it and can transmit data from one object to another of people. With the help of internet, it's known as data. And we have many IoT devices, for example, wireless sensor, software, actuator, mobile phone, computer device. Yes. And here is the map of IoT device. And today, you know that we are in the industry 4. And industry 4, Internet of Things, IoT is the one main application in the industry 4. For example,
Your voice is not that much audible, sir.
sorry.
Your voice is not that much audible, sir. Can you increase it?
Okay. For example, in the smart factory, you can see that there are lots of device here, control system, adjustment, monitoring tool, sensor, HMI, or robot. Another example in the smart city with a lot of components here, manufacturing, government, mobility, digital citizen, open data, health, agriculture, energy, building, or transport. So IoT is everywhere, and IoT is very important to our life. And next is what is malware? Malware. Malware or malicious software is it either a program or the file which is harmful to the computer user. And there are many types of malware we will talk later. And this malware can perform a variety of functions such as stealing, uncrypting, deleting sensitive data, altering, hijacking computing function, and monitoring user computer activity. So what does malware do? Malware can can affect network and device and is designed to harm the device. And depending on the type of malware, this harm can take many forms and may present itself different to the user. And all type of malware are designed to exploit device at the expense of the user and to the benefit of the hacker. Okay. So how do malware infection happen? Malware, you know that malware author use a variety of faster and virtual means to spread malware that infect device and network. And malware program can be delivered to a system with the USB or over internet to the drive by download or by the phishing attack is another common type of malware delivery. And another is a common and control server. It's a sophisticated malware can attack open picture the use of the command and control server. And another is obfuscation. This means that this technique to decide to not only view full user but security administrator and anti-malware product as well. And how the malware infection happen? More sophisticated includes, for example, polymorphic malware, anti-sandbox, fileless malware. So here is a common type of malware. You can see that the 9 common type of malware: virus, adware, cookies, spyware, ransomware, Trojan horse, remote access, worm, or keylogger. A virus, you know about a virus, adware, toolkit, a spyware, ransomware, Trojan horse, backdoor, worm, and keylogger is a 9 common type of malware. And different type of malware contain unique features and characteristics. So by the report by Fortinet in 2021, Global Threat Landscape Report, you can see that it's an SOS for IoT. And by the Fortinet, they said that because this time we had to fight with the COVID pandemic, so it's possible that attack second to suffer the less than enterprise grade security inherent to many of these devices. They are now effectively part of the corporate perimeter. This is static from report from the Fortinet. And here is the figure in this report in the most prevalent malware category by the month during during 2 hours in 2020. See that in July, August, September, October, November, and December here, and prevalent right. So malware is serious in IoT device, and so how to detect malware in the IoT device? We can follow up by 3 ways. The first is static analysis. The second is dynamic analysis, and the last is hybrid analysis. It means that the hybrid means that combine static and dynamic, and it the analysis has a strength and weakness. The first, static analysis. What is static analysis? A static analysis will screen part of the application without really executing them. This technique will incorporate signature by, permission by, and component by analysis. So what is signature by? Signature by will draw picture and make distinct design to identify specific malware. And the permission by check, recognize permission request to the distinguish malware. And the component by technique decompile the IPP to the raw and inspect the definition and bytecode connection of significant component to identify the exposure. So in the static analysis, the principal drawback of static analysis the missing a print execution part and stable execution condition. So additionally, there exists problem in the apparent code computation and dynamic code loading. The second approach is a dynamic analysis. What is a dynamic analysis? Dynamic analysis includes the execution of the application on as a virtual machine of physical device, and amidst the explanation, the behavior of application is what and can be distinct. So the dynamic approach result in a less object perspective of the application than static analysis. And the code part executed during the runtime such that every single accessible part. So the principle objective of the analysis is achieve a high code inclusion even to be activated to use what any possible malicious behavior. And in the principle of dynamic analysis it requires a considerable resource with the risk of static analysis, which object is from being distributed on resource limited cell phone. So dynamic analysis is liable for the low code coverage. And the malware has been trying to recognize the emulator and other dynamic analysis framework, extending from exhibiting their payload. So some dynamic analysis framework are unable to analyze the evasion. I see some standby here. Okay, can you hear me? Can you hear me?
Yes, sir.
Yes, sir.
We can hear you, sir.
Okay. And the last approach is a hybrid. In the hybrid, it means that the combination of static and dynamic together. So this technique will gather from the examining the application and draw the data while the application is running separately. Naturally, it would lose the accuracy of the identification. And the principal drawback of the hybrid analysis it consumes the system resource and sometimes takes a long time to perform the analysis. I just talk about three ways to detecting malware. The first is static, the second dynamic, and the last is hybrid, which means that combining static and dynamic. And next, I will talk about the deep learning. Deep learning. You know that deep learning from the artificial neural network. And in the figure A, you see that human neuron, and figure B is the artificial neuron. And figure C is the biological synapse, and figure D is the INN synapse. So in the network chaining, it means that it is the process of chaining the connection weight and treehouse of neuron based on learning pattern to satisfy certain conditions. And in the neural network, the backpropagation is an important process. This process will update the weight and activation to solve the non-linear problem. If we only we don't use activation, it means that we solve the linear problem. However, in the real life, all problem is a non-linear problem, so that we need the activation function. Here is some framework activation function. For example, time, value, support, or linear. And deep learning product is the main product of machine learning, and machine learning is the main product to solve the problem of artificial intelligence. And here is you can see that what is different between the deep learning and machine learning. In the machine learning, the picture extraction and classification is separately. However, in deep learning is the same process. So there's some difference between deep learning and machine learning. You know more clearly about the deep learning needs a big data set, needs machine with a GPU. It takes a long time, and data integration is difficult compared with the machine learning. And three artists here got Turing award, they look like the Nobel award for the computer science. And here is citation of deep learning on the natural journal. So in the deep learning, there we can divide to three. The first is deep supervised. The second is the deep unsupervised learning, and the last is deep reinforcement learning. And another combined deep supervised and unsupervised, we have the deep semi-supervised. So in the deep supervised, actually deep supervised learning, we had many models, and we can use it from the library. However, deep unsupervised is more difficult than the deep supervised learning. And what is the difference the supervised and unsupervised? Supervised means that the target are labeled. However, unsupervised target are not labeled. And here is a architecture of recurrent neural network RNN. You see that there is only one gate in this model. And however, the long process RNN has limitation. So long short-term memory proposed by Hofstadter and Snyder in 1997 is the advance of INN. In this model, is the use of forget. By the forget, we can forget or remember the picture or the result in the previous step or the next step. And the bi-directional LSTM proposed by Wang et al. 2015, it means that it composed by the forward and backward LSTM. And another deep supervised learning is a convolutional neural network CNN. This proposed by Prisma in 1980 and improved by Liconvito, Benjo, and Hafner in 1998. In CNN, there are three main layers: convolution layer, mark pooling layer, and fully connected layer. With the convolution layer, it means that we will reduce the size of the the picture here, for example, we have picture, and the picture, it means that we have the magic, and we can resize the the magic to get smaller magic and keep on most important picture for the next step. It's a convolution layer. And the pooling, it means that we will use the pooling here. In the mark pooling means that we will keep the mark value in the kernel. For example, here in this kernel, mark value is one. We had one here. This here. Okay. Another pooling is the average or mean or some. We can define some pooling function. And next, the relo to meter overfitting. Relo, it means that we will convert the negative value to 0 and keep positive number. And fully connected, it means that we will plot the last magic to get one column magic. So we can use convolution pooling or fully connected many can depend on your work. And there are some famous convolution neural network here: LeNet, AlexNet, BGD, GoogleNet, AdNet. And here is the evolution of CNN. You can see that. And on model here got the bad result in the ILSV RC contest. Another model is a combination of CNN and MS10, and you can see that what is the difference between the hybrid CNN MS10. And deep reinforcement learning. What is deep reinforcement learning? Here is reinforcement learning. We have event, environment, action, state, and reward. So deep reinforcement learning is means that here is reinforcement learning, and here is deep reinforcement learning. Now you know that where is the neural network in the deep reinforcement learning. Another model is a transform model proposed by Vaswani et al. 2017. Very excellent autoencoder. Deep unsupervised learning is more difficult than the deep supervised learning. There are some famous deep unsupervised learning here. For example, graph convolution network, generative adversarial network. Yeah. You can find more detail in the paper. And then like how we can detect malware based on deep learning. Here I will show you some paper with the 12 feature. The first is the key concept in this paper. The second is the feature. Next is the data set. After that is total data set, plate of analysis, real-time detection, usage algorithm, measure value, contribution, limitation, and availability to the public. Now let's start with the first paper by the static approach proposed by S. Howe et al. The name is Droid malware detection system using deep belief network based on API code block in 2016. So in this paper, the key concept is the user static picture with the API code block, and here data set, and the total data set is 5,000 APTS. And they use in the computer and no real-time detection. The algorithm here is the DPN, yeah, and they use measure accuracy, and they get score with the 96.66. And in this paper, the main contribution, they developed the right detection system utilize an API code block to identify malware. However, the limitation of this paper is susceptible to adversarial attack and no availability to the public. And the second paper, CNN by Android malware detection by Garnett et al. In 2017. In this paper, they propose by they upload by static picture. The picture needs a requested permission, and the total data set is only 2005 IPS. And they take in a server, and it's a real-time detection. The algorithm they use here, CNN likeness, and they use accuracy and got the value with 93. And the main contribution in this paper, they propose the detection system that transform requested permission into an image format, and they use CNN for classification. And because this paper depend only on permission, with then no limitation. Another limitation of this paper is susceptible to impersonate the attack and no availability to the public. So you can see more detail is the first and the second paper here. And next is the third by Nick et al. Classification of Android application and malware is a deep neural network in 2017, and Jiang et al. A novel Android malware detection approach based on convolutional neural network in the 2018. And you can see that here is the same static picture, and they two people they use the CNN approach, and on they use computer and no real time. With the third paper, the contribution they apply multiple layer of CNN to learn the picture, and then they classify activity based on API code 7. And the limitation of this paper is subsequent to impersonate attack. And with the paper, a novel Android malware detection approach based on CNN. The main contribution here is presented deep classified Android malware detection system based on CNN and susceptible to impersonate attack. And two paper here is no availability to the public. So we just talk about 4 paper in the first approach, static approach. Next, how in dynamic approach. In the dynamic approach, I will introduce 2 papers here. The first, deep for Android, a deep learning framework for Android malware detection by online kernel system code graph in 2017. And another paper in this approach is evaluating CNN for affection movie malware detection. What is in the 2 paper in the dynamic approach here? You can see that here the data set in the feed paper is the Komodo Cloud Security. Here is Google Flight, and total data set they took on a computer and no real-time detection. The paper is part auto encoder algorithm, and the 6th paper is the CNN, and all paper is the accuracy. In this paper, they get the better result. They get the high accuracy with 93.68. And the contribution of the fifth paper, they propose dynamic behavior malware detection by monitoring the system code up and up during execution. However, the limitation of this paper is the methodology may not cover all events during execution. So with the paper, they develop a system built based on CNN and the system collected from the dynamic run of a application. So the limitation here is a application are executed for only 60 seconds, and which is not enough to capture on application event. And another limitation here is the method is not immune to evasion technique view, and the feed and SIG paper are not available to the public. And the last approach, hybrid approach, dynamic static approach are introduced to paper here. This 7 Defender Android application threat detection using static and dynamic analysis in 2018. And the last is detecting Android malware using LSTM in 2018. So with the paper 7 and 8 here, their own paper on 7 and 8 in the hybrid approach. It means that the picture in the paper 7 is a permission intent application component network and activity liners system code. And in the permission event generated by monkey tune, and the 7 in the server and 8 in the computer. And here is a user algorithm DNN and the last is INN. So the contribution of the 7 paper, they develop defense and malware detection can run on user device. And the limitation is the monkey tune used in the dynamic analysis, maybe not able to generate on the event. With the paper, they propose the LSTM for malware detection. However, the limitation here is application running the emulator for the short term. So malware can detect their being run in the emulator and refrain it from showing any malicious activity. And on the paper here, no availability to the public. So I just present a paper in 3 approach: static approach, dynamic approach, and hybrid approach. Like I mean, so and on the paper here, you can see that the CNN is important to the malware detection, and many research use the CNN convolution neural network to detect the malware. And then next experiment, I will present malware detection in IoT device based on CNN. It's a small demo only to classify malware detection by CNN. And the data set here, the mailing. In the mailing data set, content BNG image. So we check the malware with in the hexadecimal representation. We can convert hexadecimal to the binary to the image PNG is important so that we can apply the image technique view to the malware detection. And here is about the data set with the 25 malware family. Static about the malware. And our CNN model here with the convolution layer, Makkunling, drop out, then yes, we can see more clearly in this slide. And here summarize about our CNN model. And we only do experiment on 10 epochs and find the CNN accuracy here the more near 0.96. And here you available in confusion matrix score. So we can analyze more detail by the confusion matrix score. Actually, I want to demo online. However, if the demo online is need is more time, so that just you can see that here. Yeah, about the data sets and the CNN model, and we get the result. Okay, and evaluated by the confusion matrix score. So this is a simple experiment. However, I think that you can get some experiment to for your hopefully that is helpful to your research. And actually, we research in many fields. For example, in the object detection, face vision, violent video recognition, and here some our some your some our paper. And in the LMP, we have a lot of papers there. And our research in natural language processing, machine learning, machine translation, text processing, data analytics, image processing, and artificial intelligence. You can check more detail in my personal website. Yeah, I upload on to my personal website, and you can check it in the link here. And here the on the reviewer of journal I have done. And the talk some best paper of my research. So I just talk about the IoT device and malware and how to detect malware by three approach: static approach, hybrid, dynamic approach, and hybrid approach. And I present about the deep learning with the almost focus on supervised learning and how to apply the deep learning to the malware detection in the IoT device and small experiment and the logic conclusion what we talked before. And here is some reference in my presentation. So by the norm Chomsky, you do not get discovery in the science by checking huge amount of data, throwing them into a computer and doing statistical analysis of them. That's not the way you understand things. You have to have theoretical insight. Is my conclusion. Thank you for your attention.
Thank you, sir. Thank you so much for your valuable presentation. Actually, it was a clear-cut explanation that you have given based on the deep learning approach as well as IoT devices, sir. Thank you so much.
Do you have any question?
Anyone, dear participants, anyone is having any question, you can ask.
No, sir, we can go ahead. So can you please stop sharing, sir?
Okay, no question. I will stop the topic here. Thank you for your attention and hope
Thank
we
you, sir.
will have a collaboration in the near future.
Gratitude makes sense of our past peace today and it creates a vision for tomorrow as well. It is never important what language we speak, and kindness and smile on our face are always a thank you. I invite convener of this STTP, Mrs. Srilekha ma'am, Department of ECE, to deliver the vote of thanks.
Respected Dr. Shanti Prince ma'am, Dr. S. Malaruri ma'am, our most valuable invited guest, Dr. D. Kalpana, Dr. Bu Tan Hang. I am honored and it is my privilege to offer thanks on this occasion. I thank the distinguished speakers for their immense effort and also for sharing their findings and opinions on Internet of Things. I should mention the deep meaning of the appreciation for Dr. D. Kalpana on motivational speech on Internet of Things. In addition, we are grateful to Dr. Bu Tan Hung for giving an excellent coverage on malware detection in IoT devices based on deep learning approach. I am also very grateful to the department professors. Finally, I would like to take the opportunity to record my heartfelt thanks to Dr. S. Uma Maheshwari, convener of this STTP, for the right logistics support. I also thank each and every member of organizing committee and student committee member for untiring effort and meaningful cooperation for organizing this program to become a successful one. Thank you.
Thank you. Thank you. And take care.
Thank you so much all. So
Yeah.
thank you so much to spend the time with us. Dear participants, you can take a 10 minutes time so we can start the day one forenoon session, which is going to handled by Dr. Atif Shah sir, AB Semiconductor and Designs. So now the inaugural closes. So all of you please stay safe and wear your mask. Thank you all.
Okay. Okay. Thank you.